All right, guys. I've gotten a few emails about the problems at the end of lesson 8.1. So I wanted to, before I start the 8.2 videos, I wanted to just make a quick video and work through a couple of these for you, just to kind of help clear up any problems you may be having. I have discovered with my home recording studio setup that I have no way to pause the videos. Like to do cuts or clips. So to do this as quickly and as easily for me as possible, this is probably going to look a little messy. I'm going to be moving some stuff around. I'm just not going to take time to learn a new editing software or whatever. So just bear with me. We'll try to make this as painless as possible. Before I work these problems out, I wanted to review a previous video that talked about the two special right triangles, the 45, 45, 90, and then I'll show you the 30, 60, 90. We just need to remember that the legs are represented by just X for a 45, 45, 90, which indicates that they are equal to each other, and then the relationship between the legs and the hypotenuse for 45, 45, 90 is always going to be X and X times the square root of 2. Okay, so we'll use that in just a second. I just wanted to recap that. And then for a 30, 60, 90, okay, across from the 30-degree angle, we always have the short leg. The short leg is always X. Okay, the hypotenuse is always twice X, so 2X. And then across from the 60-degree angle, we always have X times the square root of 3. So these are the side length ratios that we're going to be using for a 30, 60, 90. Okay, so I'm going to put that away for a second, and let's see if we can't get number 17 on the screen here. All right, so I had a couple of requests to do number 17 and then a few at the bottom. So we'll just run through these real quick. First thing I notice is this is a 45, 45, 90 right triangle. Okay, and I'm given the hypotenuse. I don't know the legs, but I'm given the hypotenuse. Okay, so we said the hypotenuse is always going to be represented by X times the square root of 2. And here it tells me that the hypotenuse is actually the square root of 10. Okay, so then I just want to solve this equation. If I solve this and isolate for X, then I know what my two legs are, because they're both represented by X, as I showed you before. So we can just divide both sides by the square root of 2. Okay, so over here, square root of 2 over square root of 2, those two cancel out, and I have just X on the left side. On the right side, I have the square root of 10 over the square root of 2. Okay, so we talked about how we don't want to have a radical in the denominator. So what I'm going to do actually is multiply by the square root of 2 over the square root of 2, which really is 1, right? So that means I can multiply by this, and it won't change the value. It'll only change the appearance or the form that it's written in. Now this is important because I don't want to change the value of one side of an equation, but I do want to change how this appears. So when I multiply down here, the square root of 2 times itself is always just going to be 2. Right? Or the square root of 3 times the square root of 3 is going to be 3. So on and so forth. The square root of 7 times the square root of 7 is just 7. You're effectively squaring a square root, which those two things are inverse operations, so they undo each other. So you're left with just whatever was under the radical. Okay? In the numerator, we have the square root of 10 times the square root of 2. Since both of these are under the radical, they're going to stay under the radical, and then you can just multiply them just like normal. So 10 times 2 is 20. So for number 17, the legs are both the square root of 20 over 2. Okay. Now this strategy we used up here, where we had a radical in the denominator, so we had to multiply. I just realized that that's not in the camera. There you go. Sorry. We had a radical in the denominator, right, over here, like we divided, got rid of that one, had a radical in the denominator here. To get rid of that, we multiply by whatever that is over itself, so it's in the form of 1. We use that strategy a lot, okay? So that's going to be something that we need to be familiar, be comfortable with going forward on the next few problems, okay? All right, so I think the next request, as I kind of scroll down, number 22. Okay, let's look at number 22 if we can. There's number 22. I'm going to try to set it on the, sorry for the real-time editing that we've got going on. Okay, so here's the triangle. I'm going to cover up those blanks to give myself some more space. Okay, so I have, so on this one I have two 30, 60, 90 triangles. I've got a little one over here and a bigger one there, okay? Now, for the big one, notice I don't know anything. I don't know the short leg, long leg, or the hypotenuse here. So I can't just really start. I mean, I have nothing to start with. So I'm not going to start with that one at all. I'm going to start with the little one because I already know what the short leg is. Okay, the short leg is 7 square root of 3. Okay. Also, just want to point out real quick that these two triangles share a side. Okay, the long leg of the little triangle is the short leg of the big triangle. So we'll use that in a second. Now, we are given 7 square root of 3 as the short leg. Okay, so to find the hypotenuse, which is represented by the x here, we say we double the short leg. Double the short leg is always the hypotenuse. Okay, so if I take 7 square root of 3, which is the short leg, and I just double it, which means multiply it by 2. Because these two things are outside the radical, they can be multiplied together like normal, right? So just ignore that for a second. And 2 times 7 is 14. So I have 14 square root of 3. All right, that is going to be the hypotenuse of the little triangle, which is, in this case, I guess, x. Okay. All right, now, to find, let's see, let me label this a little better. So this is how I found, well, no, it's not the short leg. This is the hypotenuse. Okay. This is how I found the hypotenuse. I doubled the short leg and got 14 square root of 3. Okay. So now, how do we find the long leg? All right. Well, we know that it's represented by x times the square root of 3. X times the square root of 3 is always my long leg in a 30, 60, 90. But in this case, we already know what x is. X is 7 times the square root of 3. So I can substitute. Instead of x, I'll have 7 times the square root of 3 times the square root of 3. Right? So essentially, x became 7 square root of 3, and then I have another square root of 3 that was already there. Okay? These two things are both in the square root symbol, so I can just multiply. 3 times 3, which is 9. So it's square root of 9, which is 3. But we've already talked about how when you square something that's in a radical, you're left with just the thing under the radical. So this essentially is 7 times 3, which is 21. Okay, so we got our hypotenuse is 7, our long leg came from 7 times 3, which is 21, and our hypotenuse was just doubling the short leg, so 14 square root of 3. Okay, so keep those in mind. Now, the long leg we said is 21. Remember that the long leg is also the short leg of this other triangle. So this is 21. Okay, which makes solving the next one really, really simple. So for the next triangle here, let's look at the easiest part would be the hypotenuse. Okay, for the hypotenuse, we just double the short leg. So short leg times 2 is 42. So the length of the hypotenuse is 42. All right, that was simple. The long leg which is represented by z here, is always going to be x times the square root of 3. Well, my short leg, which is x, is 21. So if I plug in 21, it's 21 times the square root of 3. Now, that's simplified. There's nothing I can take out of the radical. So this is my long leg. Okay, so in recap, okay, I found x. That was the hypotenuse of the little triangle. Okay, we had to find the long leg, 21, because that's one that was shared by each triangle. Okay, then I used that I doubled it, used that, and I got that the hypotenuse of the big triangle was 42. That's actually y in the problem. Okay, and then the long leg, we just plugged in 21 for x. X times the square root of 3 translates to 21 times the square root of 3, which in this problem is z. Okay, so we'll do one more, and then I'm going to move on to some new content. All right, let's check out number 24. Okay, 24. See if I can zoom in a little. Make that a little bigger. There we go. All right. So here we have a 45, 45, 90 and a 30, 60, 90, and they share the hypotenuse. So the hypotenuse of one is also the hypotenuse of the other. Okay. I'm going to start with the 30, 60, 90 because it's the only one that I have a side for. Okay. And I'm actually given the long side. 18 is the long side. Well, we know that our long side is represented by x times the square root of 3. So I'm going to solve for x, because if I do that, x would represent the short side. Now, once again, these are confusing because in this problem it's z, but for the purposes of what we're doing and keeping these ratios the same, we're going to call that x for the short leg. Okay, so once I find x, I'll have it. So if I divide both sides by the square root of 3, these two cancel. So now I have this thing again where I have 18 over the square root of 3. I have a radical in the denominator. Okay, so I'm going to multiply by the square root of 3 over the square root of 3. The square root of 3 times itself is just 3. And in the numerator, I'll just push those together. There's nothing that you can actually multiply because one's under the radical and one's not. So we're just going to put them together as a product, 18 times the square root of 3. Okay, now I'm going to take my thumb and cover up the square root of 3 for a second. These two things that remaining, 18 and 3, are both outside the radical, so I can treat them as a normal division problem. 18 divided by 3 is 6. And then I'll just bring along the square root of 3. Okay, so we just found x is actually 6 times the square root of 3. Okay, so in a 30, 60, 90 triangle, if I take 6 times the square root of 3 and just double it, so 6 times the square root of 3, double that to get 12 square root of 3, I get the hypotenuse. Okay, so here's the hypotenuse, 12 square root of 3. And remember, they share a hypotenuse. So the hypotenuse of the 30, 60, 90 that we just found is also the hypotenuse of the 45, 45, 90 triangle. Okay, now we need to, let's see. So I have 12 square root of 3 for the hypotenuse of the, I've moved on to the 45, 45, 90. I've got 12 square root of 3 equal to x square root of 2, because x square root of 2 is how we represent the hypotenuse of a 45, 45, 90. Okay, now I want to solve for just x. So divide both sides by the square root of 2. It's that same strategy again. Those two cancel. So I have this thing, 12 square root of 3 over square root of 2. So now I just need to simplify. This is not in simplest form, so I'm going to simplify this. So I will multiply again by square root of 2 because I want this radical to go away. Okay. So in the denominator I have 2. In the numerator I have 12. 3 times 2 is 6. So 12 times the square root of 6. Okay, and then to simplify, I'm going to cover up the radical. 12 divided by 2 is 6. And then bring along square root of 6. So I have 6 square root of 6. This is the leg of the 45, 45, 90. And we remember also that for 45, 45, 90, the legs are always the same. Okay? I hope that helps. Please keep sending reminds, messages, send emails if you need specific problems worked out, and I'll try to get these out faster so that you can work along. I also want to remind you, I've had a lot of questions about turning work in. My understanding is the only reason you would need to turn work in is if you need clarification or would like for me to offer feedback on your work. I'll be happy to do that. But at this time, this is not to be turned in for a grade, air quotes. Okay, but if you just need help with it or want me to see your work, I'll be happy to look at it. If you want, like I said, if you have questions about what you're doing, just snap a picture of it. You can send it to my email at jmpate@tcss.net, and I'll be happy to look at it and get back with you ASAP. All right, so send those questions in. Stay tuned. I'm about to start recording videos for lesson 8-2. So if you want to make sure you get those as soon as they're posted, go ahead and I guess click on the notifications button. Make sure notifications are turned on and subscribe to the channel.